Okay, so we're gonna try this format again because it's easier for me to explain putting this all together as I write it like on a whiteboard, but obviously I'm writing it on a piece of paper. Okay, so we're gonna start, we're putting together everything we learned this unit, right? So predicting our products, balancing our equations, solubility, all of that is coming together. Okay, so what the problem will look like is I will present you with some reactants, right? And then you have to explain what the entire equation will look like in its final form. So these are our reactants. And step one is to predict. So this is sort of like our 7-step problem that goes on and on forever. So is to predict what type of reaction, right? So when we look at this, we can see that it is one thing plus one thing. So if we have two singles, right, they become a couple in a synthesis or combination. You can say either. Combination reaction, right? So that's step one. Step two is to deal with the charges. So dealing with the charges means we need to identify the charges of our reactants, right? So how do we do that? So I'm going to write the charges in this blue color. So for charges, we're going to jump to our periodic table. So let's start with sodium, Na. On our periodic table, right, sodium is right here, and it is in the column that has a +1 charge, right? So we know that sodium is +1. And chlorine goes over here. It's in the column with the -1 charge. So we know that chlorine is -1. This periodic table is going to be available, right? So we have identified the charges. Now for step 3, we are going to predict the products. So we know that because it's a synthesis reaction, these are going to combine, right? So we're going to get a product of NaCl. Oh, this is actually Cl2, but even though that's Cl2, we're still going to get NaCl combined, and we need to figure out what those subscripts might be. Remember that this right here, this little 2, that is a subscript, right? So we need to figure out, are there going to be subscripts here? So when we're predicting our products, we're writing our charges back in. So we know that Na is +1 and Cl is -1. And then those are going to swap. I know this is sort of the more confusing part for a lot of you, but this one is going over here, and this one is going over here. So what we end up with is we've taken the charges and swapped them to become subscripts. So we have an Na1, Cl1. Now obviously we can just write this as NaCl because we don't usually write our subscripts in if they are just ones, right? So now let's rewrite that. So now we are on balancing our equation, right? So we're going to write out our whole equation. So back up here we start with Na plus Cl2 turns into NaCl, right? So just to remind you guys, this part was given to us, right up here, and we predicted our product right here, and it's just going to go right in. So now we need to balance our equation. So this is going back to the earlier thing we learned this unit, right? So we're going to draw a line between. We have Na, there's 1, Cl, there's 2, right? There's 2 because of this subscript. Over here we have Na, there's 1, Cl, there's 2. So everything's good except for that our Cl are not equal. They have to be equal on the reactants and the product side, right? So our Cl are not equal. So how do we get our Cl to be 2? We put a 2 in front, right? Because that's going to multiply this 2 by this and this. So now we have 2 Cl. However, because we put a 2 in front of both of these things, now we also have 2 Na. And now our Cl match, but our Na do not match. So we have to fix that. How do we get this Na to also be 2? We put a 2 in front. So now our sodium are both 2 and our chlorine are both 2. And we have a balanced chemical equation, right? So let's write that down here. I'll put the coefficients. Remember that these numbers right here are called coefficients. I'll put those coefficients in red. So let's start. So we have a 2 Na plus Cl2 turns into 2 NaCl, right? So that should look familiar. Here we are with all of our steps. We are not done. Our last step for step 5 is solubilities, right? What we just learned in the last lesson. So solubilities are when we use our solubility table that looks like this to determine if something is going to be a solid or an aqueous. Remember, aqueous means dissolved in water. So either it's solid or dissolved. Okay, so I'm going to write those in this dark blue. Okay, so if something is alone, right, it's going to be solid. We're just going to assume that it is solid. It might be a liquid or gas, but for now we're just assuming it's solid, right? So we know that Na, because it's alone, is going to be a solid. Cl2 is also alone. It's a solid. Now we jump over here. Now these are not alone, right? This is 1, 2, it's a compound. So when we have a compound, we need to go to our chart. And our compound is NaCl. We go to our chart and we look in this first column and see if anything in NaCl is in there. And we see that Na is right here, right? And we go over here, it says always soluble. There are no exceptions. So we know that anything with that Na is always going to be soluble. So this is going to be aqueous, right? Just to remind you, solid means not soluble. I know it's a little confusing. I can't spell soluble either. And aqueous means soluble. There we go. Okay, so see how we determine that? If it's alone, it's a solid. Since this is a compound, we went to our chart. We saw that sodium matters and that sodium makes it aqueous. This is a Q. So now our final step is to write our final equation. I know we're finally there, guys. Which is going to be, I'll write it with the little fun colors, 2 Na solid plus Cl2 solid becomes 2 NaCl aqueous dissolved in water, right? That is a balanced equation. You predicted the product, right? And you determined the solubilities. So this is our final product. I know that's a lot of steps, right? 5 somewhat complicated steps to determine your product. And this, of course, is a simple synthesis reaction. and things do get more complicated when we do a single replacement, double replacement, anything else, right? So I'm gonna show you those examples as well. Okay, so let's flip over. Now we are gonna do a single replacement reaction, right? So number 2, this is our second example. We're starting with Si2O4 plus Mg. So that's what we're starting with. So our step 1 is to determine what kind of reaction it is, right? So we're gonna go, and because this is a couple, right? This is a compound, two things together with a single, couple plus a single, means it's going to be a single replacement. Single replacement reaction, right? So then our step 2 is to determine the charges on the reactants, right? So Si, we're gonna go back to our periodic table, right? So we see that Si is in the 4th column, or that +4 column. So Si is going to be a +4. And oxygen is in that -2 column. So it's -2. You may notice on your periodic table, it may say +4, -4. Obviously, since oxygen is negative, this needs to be a +4, right? And then Mg is right here in our +2 column. So we've determined the charges. Now, let me show you sort of a quick and easy way to determine the charges in a couple, right? So you may notice that this 2 is the same, and this 4 is the same, right? That's because they did that crossing over. So if you want a quick way to determine the charges, usually this 4 is up here and this 2 is up here. That's not always true, but that is sort of a quick, easy way. But you can, of course, always go to your periodic table to determine things like that. Okay, so we have done the charges, right? Now step 3 is predict the product, right? So here's the key. When you are doing single replacement or double replacement, you swap the positives. So the things with positive charges, Si and Mg, you're going to swap them. And this is true in double replacement as well, right? So this is going to become Si on its own plus MgO. Now I'm not putting any subscripts in, right? Because we have to determine those. So Si, it's all good on its own. We can just leave it alone. We don't have to do anything to it because it's a single, right? When you're single, you don't have to do anything. However, in a couple, you have to make sure that it goes together nicely. So we're gonna put in our charges. Mg is +2. These are determined up here in step 2. And O is -2. And then we're gonna swap those, right? So what it becomes is Si, just the same because it's single, don't have to worry about it. And over here, this is Mg2, and then O2. So those are our products, right? So now step 4 is balancing our equation. So let's write our whole equation, starting with our products. Si2O4 plus Mg turns into Si plus Mg2O2, right? So remember that this products part is what we just determined. The reactants part comes from up here. Okay, so let's balance that equation. Draw a line. So we have Si with 2, oxygen with 4, Mg with 1. Over here we have Si with 1, oxygen with 2, Mg with 2, right? It's easier if you line the elements up. So we can see that these are not equal. So let's start with Si. So to get Si equal, we need to put a 2, we'll do it in red, a 2 in front, right? So now this becomes 2, a 2 as a coefficient. And now we need to get oxygen equal. So to get oxygen equal to 4, right? We're not going to put a 4 in front, right? Because it's already 2. We're going to put a 2 in front. Let's see why that makes sense. Because 2 times 2 oxygen is going to be 4. Right? So, because if we put a 4 here, it's going to be 8, and we don't want that. That's too many. We want it to be 4. Okay, and then, but because we put it in front of a compound, it's also affecting Mg, right? So 2 times 2 Mg, now this is 4 Mg. Go back over here. How do we get Mg equal to 4? We put a 4 in front of Mg, right? And now it is equal to 4. Okay, so step 5. This should be a balanced equation, right? Si is 2, O is 4, Mg is 4. So let's write out our balanced equation. Si2O4 plus 4 Mg equals 2 Si plus 2 Mg2O2, and it's time for solubilities. I really cannot spell solubilities there. Okay, so let's do this. So here's the key. We're gonna check our solubility chart because this is a couple. So let's go through first. The singles, right, are gonna be solid. Any singles are solid. Don't have to worry about them. Si2O4 is a couple. So now we need to go to our table. And we're gonna look in this column and see if we see any silicon. Let me make sure it's, okay. Any silicon. I don't see silicon at all, and no Si, and I see no oxygen on its own. Now obviously oxygen is present in this, but you have to have that whole compound, which we don't, right? You have to have that whole compound, which we don't. So there's no oxygen and no silicon. This is just sulfur, not silicon, right? So if it does not exist in the table, you assume that it is a solid. Now let's check this one. MgO2, a couple. We go to our table. There is no Mg and there is no oxygen on its own. So you assume it's solid, right? So now we can write our final equation. So it's not in the table, then assume it is solid. Final equation is Si2O4 solid plus 4 Mg, also a solid, turns into, I just jumped down because there's not enough room, 2 Si solid plus 2 Mg2O2 solid. So we predicted the products, we balanced our equation, and we predicted our solubilities. That is our final complete equation